Hello everyone. So here is the second part of your notes for 1.3. It is the distance formula. All right, so once again, we have here on the coordinate plane, point A and point B. Now, again, A, since we don't know the coordinates, we can call the coordinates for A, x1, y1. And then for B, same thing, x2, y2. All right, now what the distance formula does is it helps us to find the distance between point A and point B. So that's going to be this length right here. And I'm going to go ahead, I'm going to call this length D, AB. D, AB stands for the distance between point A and point B. All right, now how we find that is like so. So the distance between points A and B will be equal to the square root of x2 minus x1 squared plus y2 minus y1, also squared. So we're going to go and we're going to use this formula to find the distance between these 2 points in the next several examples. Let's go and get started. All right, so first example here. It's asking us to find the distance between points R and S if R has the coordinates 2, 3, and S has the coordinates 4, -1. All right, so first things first, let's go and let's get that formula down one more time. So the distance, but now instead of between A and B, we have points R and S instead. And this will be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, and just like before, our x2, y2, x1, y1 come straight from the coordinates. So for R, I'm going to go ahead and call 2 x1 and 3 y1. And then for S, 4 is going to be x2 and -1 is going to be y2. So now that I have everything labeled, let's go ahead and substitute in. So the distance between R and S will be equal to the square root of x2 is going to be +4 minus x1, which is going to be +2. All of that gets squared plus y2. Now, y2 is a -1. So when I substitute that in, I want to make sure that I use parentheses. So there we go, -1 minus y1, which is a +3. And this, of course, gets squared as well. Now, from here, we go ahead and evaluate using PEMDAS, or our order of operations. Taking a look here, we do have some parentheses to deal with, so let's go ahead and let's do the calculations on the inside of these parentheses first. 4 minus 2 is just 2, but let me go ahead and rewrite the equation. The distance between R and S is going to be equal to the square root of 2, and 2 is getting squared, plus here we have a -1 and I'm subtracting 3. So if I have a -1 and I'm going more negative, this gets me to a -4. And yes, I do want to write this in parentheses. The key here is knowing that when we square a negative number, it's going to become positive. That's why these parentheses are super important. If you forget the parentheses, what we actually end up squaring is just 4 that gives us 16, but the negative is still there. So we get an answer which is negative 16, but that's not quite correct because again, negative 4 squared means negative 4 times negative 4. So that actually gives us a positive 16. But again, let's take a moment to rewrite the equation. The distance between R and S is equal to the square root of 2 squared is just a nice simple 4 plus negative 4 times negative 4 is a positive 16. All right, finishing this up, this is going to be equal to the square root of 20. All right, now very quickly here, I want to talk about simplifying square roots. Now, when we simplify square roots, here's what we're actually doing. We are going to go ahead and take our radical, in other words, our number inside the square root, and we're going to factor it. So I'm going to take this 20. I'm going to go ahead and factor it into 4 and 5. You can, of course, factor this into 2 and 10. That will work as well. And then I'm going to continue to factor until I can no longer factor anymore. So this 4 can still be factored into 2 and 2. All right, and then what I'm going to do now is I'm going to take the number at the end of every single branch. So from 20, I'm going to follow the branch on the left down to 4 and continue to this 2 right here. And then, of course, following the other branch, I get another 2. And then the branch on the right that is connected to 20, that one ends with a 5. All right, and then now what I'm going to do is I'm going to rewrite the radical in its factored form. So the square root of, and keep in mind when I say factored, that means that we're dividing. So when I put these numbers back together, we are going to be doing the opposite, which is multiplying. 2 times 2 times 5. All right, what we're looking for here is we are looking for pairs of numbers. And then if I do have a pair, here's what happens. One of the numbers in the pair gets canceled out. And then the other number in the pair, we will move it to the outside of the square root. And then any number left on the inside is going to remain on the inside. So I have a pair of 2s. One of them gets canceled. The other one comes out. So I have a 2 on the outside. And this gets multiplied because, again, the operation on the inside was multiplication. And so when we bring it out, it remains multiplication. 2 times the square root of 5. And this right here is our exact answer. Alrighty, now we have an exact answer, but there is also a way to find the approximate answer. And the only way to do this is to use a calculator. So when we put this into a calculator, you can do 2 options. You can go ahead and put the square root of 20 in to your calculator, or you can say 2 times the square root of 5 into your calculator. Both of these will work. But regardless, here's what we get after putting it into a calculator. The number that we get is 4.47213, etc. And the number continues. Keep in mind that this number, square root of 20, or 2 times the square root of 5, is a never-ending decimal. So what happens is that we need to round it. So let's go ahead and let's round this to the nearest tenths. The nearest tenths is going to be the first decimal place. And in order to round, I look at that number, the first decimal. But I use the number next to it to figure out if I need to round up to 4.5 or 4.5, or keep the number as 4.4. So in this particular case, the number next to the 4 is a 7. So that tells me that my number 4.4 needs to get rounded up to 4.5. This is our approximate answer. So 2 different answers but it's good for us to know both of them. All right, go ahead and pause the video here and see if you can give this one a try on your own. All right, so go ahead and double check over your answers. Now, one thing that I want to mention about this problem is, again, to make sure that when you substitute in negative numbers, please use those parentheses. Because here's the thing. In the original formula, it says x2 minus x1. Our x2 is a negative 3. So we go ahead and use parentheses. And we need to subtract a negative 6. So when we subtract a negative 6, we have these double negatives. If you don't use these parentheses, you might accidentally forget to write down one of these negatives. So that's why these parentheses are really important. The other thing also is that we might have to change the operation here. And so in this particular case, because my two negative signs are right next to each other, this turns into addition. So I took a moment to rewrite the entire equation so that I know what operation it is exactly that I'm doing. So I have negative 3 plus 6, and that gives me a positive 3. And I'm going to square that. Over here on this side, 1 minus 5 is just a negative 4. Again, the negative 4 needs to be in parentheses before you square it. If you forget the parentheses and you try to put it in a calculator, it's going to give you a negative number, which is incorrect. Finally, we finish with the square root of 25. And when you put this into a calculator, this gives us a perfect number 5. So in actuality, this problem doesn't actually have an approximate number. We only have one exact answer. Alrighty, so that is it for this video on distance formula. Thank you very much for watching.